All right, so we've got a new theorem. It's different than the MVT, the mean value theorem. This one is going to focus on whether or not you're guaranteed a max or a min. That's all. That's the whole point of it. And if you notice here, this is an if-then statement. And one of the great things about geometry, when you take some rigorous geometry class, is that you get into these if-then statements, and then you understand that an if-then statement can be true even if the excuse me, I gotta plug in my speaker. Even if the if part is actually false. Okay, so the point is that you can have the EVT fail, but yet still get a max or a min out of it. Okay, an absolute max or an absolute min. So what they're saying though is that if an f is continuous on a closed interval, then it's going to have a highest value and it will have a lowest value. And I know that sounds very common sense, but it actually took a while to actually kind of prove that in a rigorous way that this is actually true. Okay. So also keep in mind that extreme values can occur at endpoints of the intervals. Okay, so absolute maxes and absolute mins can occur at the intervals, but not relative maxes or relative mins. Okay, now let's see. You can have a max or a min. You can have both of them. You could only have one of them, or sometimes you have no extrema. So let's look at those examples as they kind of play out. So what we'll do is we're going to find the max and the mins here, but we're also going to state whether or not the EVT actually applies. Okay. So right here, if they're saying that we have to go from 0 to 3, so it's closed. Okay. So this means then from 0 to 3 that I have discontinuity here, and it did say in the if statement that there has to be continuity. Okay. And because there is none, or there's a break in the continuity, EVT does not apply. Okay, because not continuous. All right, it's not continuous on 0 to 3. Okay, however, there's still a max and still a min, and we do have an absolute max and an absolute min. Okay, and that would be obviously at x equals 1 and x equals 0. Okay, so all right, EVT doesn't apply. Okay, but there still is an absolute max or min. Okay, same thing here. Okay, EVT does not apply. In fact, what I just feel like doing is let's just write it a different way. EVT fails because it is not continuous on 0 to 3. That's yet another way to write it. Okay, is there still a max or a min? Is there? Okay. Now let's look at the absolute max. Is there an absolute max? And the absolute max actually is happening at 0. Okay, so we're going to put x equals 0, but we could also say that the absolute max is 4.5 at x equals 0. Okay, but what about the absolute min? Now here's where it's a little interesting, because you might want to say that it's at 1.5, but you'll notice that there's a hole there. And so because you really you need an actual value there, and we can keep choosing numbers closer and closer and closer to that open circle, you never actually figure out what that min actually is. So he actually is a DNE. Okay, there's actually no absolute min there because that bottom piece is actually undefined. Okay, so kind of keep that in mind. All right, how about this guy from 1 to 3? Now notice right there at 3, this is not closed right here. And same with here. See how that's open and that is open? So this means that this guy actually, this is another EVT failing. Okay, because we're basically saying that it is just not continuous. Okay, and we got an asymptote there at 3, and 3 is supposed to be closed. We're supposed to have something there. Okay, so is there a max or a min? So the maximum value would have been right here at 4.5, but notice that it's open. So ABS max okay, is a DNE. All right, and then for a minimum, it looks like we actually have an arrow. So that also is a DNE. Okay, so here it fails outright in all situations. Okay. Now here's kind of an interesting situation. We are from from 0 to 3, but you'll notice that it is actually open at both. Okay, so the EVT does fail yet again. Okay, because it is still not continuous. Because it is not continuous. Okay, on. Now what I'm going to do is I'm going to circle those closed brackets, because you can clearly see that it is not the case. They are not closed. They are open. So therefore it is discontinuous right there at the ends of the window. Okay. Now we can still have a max though. Okay. In fact, this is an ABS max, and you can see that it actually is 4 at x equals 1. Okay. I can write it like that. The min, let's see. Do we got a min? Yes. It is actually -1 at x equals 2. Okay. Both are completely, these guys are just fine at communicating that way. Okay. All right. So the extreme value gives us, theorem gives us the knowledge of when extrema occur. Okay. But how are we going to find them algebraically? Sometimes we don't have the luxury of having a graph. Okay. And so we only have it algebraically, so that's more powerful anyway. Then what we can do is we can just determine whether or not the EVT applies. Okay. So this is kind of like the MVT to see whether or not that applied. Each function shown below, for each function, justify why the EVT can be applied or why it does not apply on the given interval. Okay, so just looking at this guy right here, I hope you recognize that right there, okay, x cannot equal 2. Okay, so is 2 part of our closed interval? And the answer is yes. It means that we're actually going to have an asymptote. Now, we don't have the graph, but we know that we cannot actually equal 2 in this case. And so EVT does not apply. Okay, does not apply on -4 to 4 because f, I'm writing out, because f is not continuous. Okay. All right. And it's because x cannot equal 2, and 2 is part of that domain. All right, what about this guy? Is he continuous? So let's just take a second. Now, we don't have a graph, but let's see if we can figure this out. This guy's an exponential, and so he always has like a, he's just either a curve like this, a curve like this, a curve like this, and then what's the last one? This guy. Okay, he's always one of those. So there's never a hole for him. Now this guy is actually, because we got a +1, he's going to move up 1, and then because x minus 2, he's going to move over to the right 3. And so this guy's going to, well, right there. So he'll look kind of like this. Okay, and is there any issue in the domain between -5 and 5? And the answer is no. So we can say EVT applies. Sorry, I'm getting sloppy writing. This kind of marker, these thin-tipped ones, make me write sloppy. Applies because G is continuous. G is continuous on the interval -5, 5. Okay. All right, this guy. Watch out for square roots. Okay, so like I was saying, you've got to watch out for domains, because for the ones that are 1 over x's, okay, in this case it's a 1 over x minus 2. Watch out for those guys because they have domain issues. And then these guys here with a radical sign, those guys also have domain issues. So now we just have to determine whether or not we're going to have a domain issue from -6 to 6. Okay. All right. So let's just go over here to +6. You can see I'd get a 6 times the square root of 8. That's no problem. But let's go to the negatives, because the radicals don't play well with negatives. You need to kind of know the border here. Okay. If I plugged in a -6, I would be taking the square root of -4, and that is automatically going to break the whole process, because then we got a complex number, and it's not for us. Okay. So what we would say is, okay, is that since here's another way to look at it. Since h is continuous for values only x is greater than or equal to -2, okay? -2 would give me a square root of 0, and that's okay. But anything less than that, then I'm going to have an issue, okay? So since h is continuous for values only greater than -2, EVT does not apply to the interval -6 to 6. Okay? All right, so that should cover that part. We're going to go ahead and do the critical numbers tomorrow. Okay, and that's going to have some extensive algebra where I think we should do it in person. Okay? All right, I hope that was quick enough. Yeah, 11 minutes, not bad.